Hello everyone, and today I want to show you the thought process, the way of translating it into Rhino and Grasshopper, and the overall idea of how to get a project starting with an idea or a thought and then translating it into a real geometry that you can actually see and touch. So let's get this started. It's more of a thoughts idea video. Perfect. Okay, so just like how we have this here, as you see, we have this gigantic building, which is obviously completely parametric as well. We can change the parameters according to our needs, and the whole building will update on the fly while we're doing so. And it's very useful because we can just basically very easily shift between thoughts and ideas and the way of how we can apply them in a very direct manner. And I think it's very useful to use Grasshopper and Rhino with it because it helps us a lot more. So I just will go through a quick presentation and show you the way of how I was thinking about this, and then of how I was applying this directly into the Grasshopper environment. So just to recap a little bit, we had this thought process of corridors and entranceways and hallways, and how they basically existed from the 1540s on, and before they actually didn't exist, and there was this walk corridor, and then it went to more of a residential corridor, and how during like a pandemic we should reduce the amount of corridor that we have to or make that wider or multifunctional. So then I made a few simulations which were actually made also in Grasshopper itself, or with plugin called PED Sim, PED Sim, that can basically simulate certain ideas of movement patterns, and this is something I want to incorporate in a later stage. And then I was looking a lot, or I got some inspiration from Fun Palace concept, which was made by this lovely human called, wait a minute, I have it here in a second, called Cedric Price, as well as the Centre Pompidou, which is by Renzo and Richard Rogers, and the idea of the Uniklinicum Aachen, which is a building which has also this like structural outer facade where you can see the inner workings basically from the outside, as you see here at the moment, and which is made by Wolfgang Weber and Peter Brands. And now then this idea of drawings came in first. So I was okay, there are certain connection techniques of how you can look at a building and how exactly the connections can work. For example, here you have a cantilever and like a very small column in the end that connects it to the ground. Here you have a hanging structure, and there are also the connectivities between those structures, how that actually work, and also a certain kind of circulation that happens as well. So those were like my first thought ideas. And then this is also some German words here, some construction techniques of how to apply those. So the word doesn't really matter, but what it matters is basically the concept idea of it, just like a simple section of what I want to actually do. And then I crafted a room concept of where the rooms are, or the multifunctionality, the shared functionality, a public-private space, and also what is special in my concept, basically this kind of branching out or distribution of function as well. So you go more public and more private, private. And with that, taking in mind also the general construction techniques that you use in columns, for example, going into the z-axis, which would be later also relevant in Grasshopper, and then providing space with x and y, and then also certain like a structure that is provided as well. And now we go to the maquette, to the model. So this was just basically a very simple, okay, how do I want to distribute that from bottom up basically, and how I could then specify more of how I think those things could look. And then continuing that, I just applied some general textures to it, and putting it on the area that is necessary. In this case, it's the Tempelhof Airport in Berlin. And seeing the connection of the runway that was there, but which is decommissioned at the moment, well, forever, and then also taking the axis of the rather long street, and also the neighborhoods is a little bit as well. And so here we have like this diagrammatic approach that is already now like the result of our Grasshopper technique, as well as a more kind of suited look to it of how this could actually look like in a modular space more. So you basically have a free open space down there, so it's free and airy, and then you go up, it gets a little more closer, and there are certain spaces where you can visit and see people, and in the top space it gets more private, and each person has his own kind of ideas and thoughts. Perfect. Now when we go to the script itself, I will try to basically move you through there how this thought process goes and try to explain this one by one. Okay, perfect. So we were starting with a very simple rectangle. First, like this one here. I think it is actually another one. Yes, the one at the bottom. And there is this plugin from I think it's from Lunchbox, yeah, and it's structure, and you can basically apply a structure in the area as well. And we define it with the U and the V division. And this one then, I already have it now baked here in the Rhino geometry. It basically shows this would be our basic structure that those things are happening on. By the way, there was also a obviously a different alternative, as you see here, because I had those vertical columns in here as well, like those ones here at the side. But I actually want to remove them for now because I didn't actually wanted to use them. So just to give this in context, I created the script like in basically one day, and it helped me to trying to find the thing. Where do I have it? I think it's actually okay. It's this one, right? Yeah. So just to start so we have the structure here. And then I was starting first out, I think it was, okay, I was dividing the rectangle that I had, and I was dividing it into a surface as far as I know, or rather in two different like parts. So here this basically, first of all we have the segments, then each segment gets from one place of the curve to the other, so basically we get those places of the curves. And then those curves, we look at the length of the curve, which then in the end creates basically this rectangle on top. And so we have basically we calculate the length of the rectangle, like the y length here, and we divide it by the division points that we were defining in the beginning to know how many rectangles we have to place, and or no, what size they actually need to be in the end. And this then will also take in mind this thing here, because we have another thing that's called divide surface, and we basically take this rectangle surface as well, which gets divided by the same amount of points. And when it gets divided, we also are removing certain other points. So if you go in here, you will actually see. So you have a certain wrap basically, which was like a very simple shape there in the middle. We get to this later. And then it removes points that are closer to it or not. So basically, what this basically makes is that, so if you look now on top, it removes here in this area where you have those core functions. We don't want them, actually here is a little glitchy as you see, but we want them to be removed. So we don't want any things that are happening here. We just only want the points that are on the outside. So as you see, the points get created, but the points here in the middle, they do not get created. Perfect. Now then we have this, so the basic rectangle size, and we want to now create a pattern of how often we want to remove one of those rectangles in order to keep this airy and light. And here we have it, basically we measure the length of the curve, or the length of the amount of rectangles that we have, and we divide them into a certain pattern, and this pattern then basically dispatches those. In here there's a little bit random, I should remove this one, but we basically removing. So by decreasing the pattern size, it gets more dense, as you see. Yeah, and if we increase the removal calculator, basically we getting basically a more open space. And this simple thing does is it takes a look at the list that we have, then it gets values, and the dispatch pattern is it so that you only create a dispatch between, if the dispatcher is 1, it is a 1 or more, it would be true, and if it's 0, it's false. And so it gives us a false and a true, basically. So this one would be the false one, this one would be the true one. So if it's more than 1, then it gets removed further, and because in our series the numbers are from 1 to 6, so there is a more probability of them being a high number, we want them to be removed from there. Then from that on, we have our dispatched patterns here, and we want to basically distinguish between them again as well, in order to create those kind of rooms where you can look downstairs, or patterns that you go a little more further up here. So those then get distributed into, I want to have them in 3 different ways. So one time this will be the build areas, other time would be just slabs in there, and the other ones would be open slabs where you can actually look through. So this would be then just a very simple box rectangle that is defined here. We can also obviously make it thicker just with the click of a button, as you see, or we can also make it very small and slick, depending on the need, how we want to have it. I think this is actually a bit too less, because then the structure will be shown there. I think 0.3 meters would be fine. Perfect. Then this gets just very simple box extrude. It's a very lightweight component. It can extrude a lot of boxes very quickly, so we have no problem with rerunning the calculation. So this is this box, and the other rectangles define the open rectangles here, which I want them to be those ones here. They are the rectangles that get a little bit offset, so we create basically this middle piece here, and then it gets merged together again with the offset surface. And then there is this component, it's called from pufferfish. You can basically, you can also make it yourself, but pufferfish makes it a little bit more easier and straightforward, which basically extrudes the things upwards and closes the surface around it, so you don't have to do this like whole calculation yourself. It is also possible, but it takes a little bit of time. And then this already gets baked. So this is, for example, like the path how this gets created. Then the other ones are the building blocks, are the things where people would like to live in. Those would be the dispatch from the one before, and being the false dispatch from the curves here in the beginning. So they are basically the lesser amount of things that there are. Obviously, we can, if we decrease the slider, the amount of boxes for living increases. So now we have that. This is actually a bit lazy work, I would say, but okay. But we have, first of all, the amount of how much we want to put those things upwards. As well as you see here, we can rather simply move those upwards and downwards. And then I simply just made from those a dispatch again. So I just made a I divided them by basically 2, and I have then now 2 boxes here that get moved upwards, and this I do basically again, and they're moved upwards again, and then again, and they move upwards again. So this is in order then to create this kind of, you see, you have like one top here, one more top there, and more down there. So it basically gets a little bit like a lighter on the way to the top. So then this is already the place for the rectangles here. And then we also have, there's another one, because I was feeling that the downstairs area was kind of like a little bit too like not spaced, so I was moving those things in here in order to, if you see, I just used the height, moved it downwards, and then we simply also had the same rectangular here in the downstairs area. Good, and this then also gets, I get to this later, it's the human baking part, but it's not so important right now. And then we also have, another very interesting component as well, because if I click this button here, and I create it to true, you see there will be another part here in the end, because before it was only those parts here in the middle. But now I can basically shift around between the one option or the other option. And this gets very easily done by this gate, because I want to define the amount of B reps basically that gets removed from there. And I also want to know I basically check if, let me go inside this one here. I am, because I want to, I don't actually know exactly what it exactly does at the moment, even though I programmed it, but we have this amount of gate which says true or false, and this basically dictates if I will, it basically dictates another piece which says we have a ground amount of points, and if the thing is true, we will remove the last and the first points, and if it's false, then we would take all of them. So here you have all of those points. You see 1, 2, 3, 4, 5, and if it's true, it uses them, and if it's false, it uses basically those other ones. You see, then this point here at the end, it gets actually added to it. Great. Actually, when we're here, we can continue with this. So basically, we have this another surface as well. It's a very simple one. This rectangle surface how we had it in the beginning, and we want to check the surface as well and take the one piece from the other piece, because we want to create a pipe pattern that goes from the top of our structural component to the end of our the structural concrete component to the end of our steel construction, which would be here in the middle of our things. And because it is a curve that is rectangular, so it goes into one direction, so we need to distinguish this curve from this other curve, because this curve over here basically is rotated 180 degrees, so we have to basically flip it around, and then we make a division of this curve as you see here. And when it's divided, we want to create a list of points depending on the list of extrusions that we had here. So we had those rectangles down here that we created earlier, and they are then also moved upwards. And if those are divided 6 times, we also want to divide a pattern here 6 times. So we have basically this one then has to be partitioned into several lists in order for them to be connected properly, as well as our own creation of the rectangles that we created there. And then it just very simple, we just created lines between those, and they're moved downwards, and then because they're moved downwards, we have this kind of rope-ish thing going on, which is not that correct at the moment. It has to be completely redone, but that's like how those pipes here also work. And then those go on this point that we defined before, and the endpoint C is a new point for the new number slider, for the new point like SDL, like the direction line, which is I think this one here, yeah. And it creates a downwards line that will be connected to the last point here from our structure on the second floor, so they get connected together as well. And that then obviously the pipe command. Okay, and then we also have this is one other, because we have the rectangles that we defined here before from this curve here. So we have basically the rectangles from the plane of those things that we defined before. If they're true or false, they can be used or not, and they then get moved upwards to this stage, and then they're moved upwards further as well, because this size is also a little bit higher. And then those things, am I on the right one here? Yeah, and because we want to create those ramps here in the bottom, we basically have we use those points and basically go around them, and while we go around them, we want to repeat how they go around there, or we want to repeat the points, and then we want to move those points that are repeated downwards, you see here, and all the way to the ground. We can actually also increase that, right? So yeah, can make the ramps a little bit more well, usable, more or less. I would say this is a very long way up, but that was like the idea we also had before in the diagram that I showed you. And then it just simply makes a simple offset, and then another offset, and then it gets connected together, and then it gets extruded, and then you get just like a handrail, even though it's I think all a little bit buggy. I think if I would display this in another viewport here, preview, mesh, where is it? Display. I think it previous settings. Yeah, and then no, view, display. Should you preview mesh edges? Canvas widgets. Here, preview mesh settings. Yeah, I cannot see today, and this should be displaying it more correctly, I guess. Not well. There are also some mistakes here, I guess, but they were not that visible from afar. So I guess what you see is what you get. Anyhow, and this then gets very simply then connected together, and then also moved to just displaying it correctly. Let me actually just hide those things here. Perfect. Then there was another point. Yeah, exactly. I think I displayed. So I talked about the lines that we created that are downwards from there, and then the extrusion is moved upwards from the bottom. What is actually very interesting, I was creating the script for another Grasshopper tutorial, and all those people, right? And actually, when I click this button, they actually will move towards me, or so they should, as you see here. And this is a very nice script because when we go inside it quickly, it might take a while actually to close this down again, but I think that's worth the risk. This is actually a script that we used in another Grasshopper script, and it takes basically a PNG or an image of a file, and then creates a surrounding silhouette around it. And this surrounding silhouette, then you can see it in the video. I will have it in the description, and you can look at the video. It creates a silhouette around it, and then it gets rebuilt a little bit, and then those points, like those are the figures there, and then they get placed on top of the geometry that is populated, and then this populated geometry has a checks the viewport, which is actually a human plugin as well, from the plugin Human, and this one then will create a distance between the camera and the points here, and you basically have this. I think you can actually see it if I would just create the line between the camera location and the location here, and this one here. Yeah, I guess so. It needs to be the correct one. Oh yeah, you see, it will always create this camera location, and if I updated it basically, because before we were looking from there, and if I update it with a button, for example, like this, then it will just like create the from where the camera where I was, and it will always like face me. Anyway, this is discard all changes, close. No wait, return to parent. Yeah, so this is basically the script here, and it will create all those people because I didn't want to put them in hand in Photoshop. It will take a lot of time, and this will actually make it really quick and easy. And as you see, I sometimes want to increase or decrease the amount of people, so that's pretty good. I think I actually need to put another randomizer in there in order for it, because right now they're very military up there. Down there it's better, but it's because it's every single surface, and they get created all over again and again. Anyway, and now we have the final thing that is just a very simple kind of way. We have a way of baking those things as well, and this is with the component Human, and it basically has those. I was talking about another tutorial about this as well. It has those very straightforward things of, okay, I have the geometry that I want to bake, and it has certain attributes, and the attributes I predefined in Rhino already. So we have like I have 4 different spaces, like public, private, shared, structure, and I want to create this structure then as well here. So I put here the one is this public, this is the shared, this is the structure, and this is the private. And then by a click of a button, this one here, I can very simply bake it. I will not do it now because I think I already baked it as well. If I just deactivate those here, and I will put the geometry as no preview, and I will activate public. Yeah, and you see it's I should have actually made a picture for this, but like, yep. Public, private, the shared space, the structure, and the people as well. So yeah, I think this basically covered it. So I hope it helped a little bit, because it was going from the whole idea to an actual kind of concept structure or concept idea as well. So now I want to basically continue, because there are certain things that do not work out, obviously. For example, the ramp down here, I want to have some greenery that it goes up into a certain locations or at certain times, and I also want to create a more detail, because right now we're just only talking about boxes, but it would be very cool to create boxes, for example, that are more detailed, and you can say, okay, here, depending on the distance to the view, we can create a bigger structure here, or depending on how many people would be in this area, there could be more open space here, and all those kind of things. So this is what really, where Grasshopper really shines, this kind of automation as well. So we can very simply just, if I would like to change the amount of people, I can very simply just like bake it as well. Then it would create it like this. You see, well, right now they're always like, well, just let me hide this quickly, and then I was, okay, I'm happy with my new idea, boom, baked it, and there it is again. So right now they're different. I think they're on different layers, so that's why the structures are different. So this is like really easy to make and do. And for example, when I just simply change this one like this, and I want to change I now deactivate all the things, but that's fine, and I will change this one to that. We are very quickly, it will recompute those things. It would take a little bit of a while, obviously, But once it computed this thing correctly and it doesn't crash, which sometimes can happen, but it didn't, as you see, perfect, you can simply click the button and it will generate the same thing for you as well, again, in a matter of seconds. So yeah, thank you much for watching. I hope you learned something from it, and yeah, have a great day. I hope this was a little bit of a different video because I was talking more of the idea of it, and I was talking for like 30 minutes, which is quite a long time. And I hope it kind of made sense to get through the thought process of how I'm approaching a project with a parametric idea in mind, at least. So to basically use my thoughts and ideas in order to deliver the practice in the right and meaningful way. So yeah, thank you very much for watching, and see you in the next one.